So this is Chapter 9, Section 5. You can look up in the PDFs. This is Chapter 9, Section 5, Day 1, if you want to look up the PDFs and print out the PDFs of this. Or this first part is on Course Pack on page 903. After this one slide, the rest you would have to do on either the PDFs, which you can print off from online PDF, Chapter 9, Section 5, Day 1. Or you can just do it on your regular paper. So this is going to take a little bit. Let's see what we can do. Let's look back on things that we learned in elementary and middle school about adding, subtracting, multiplying, and dividing fractions. Remember how this works. I have 3 and 7 as my denominators. I want a common denominator. So I need to decide what's my least common multiple. My least common multiple to find my least common denominator, my LCD. What number does the smallest number that both 3 and 7 goes into? Well, that's going to be the number 21. And so then the question is, 7 times what? Well, 7 times 3 is 21, so I have to multiply 5 times 3. 5 times 3 is 15. 7 times 3 is my 21. Here, I want to do the same thing. 3 times what is 21? Well, that's 3 times 7. 3 times 7 is 21. So 2 times 7 is 14. So now I have the exact same problem, but now I have a common denominator. 14 21sts plus 15 21sts is going to be 29 21sts. If I wanted to reduce that, I can reduce that, but an improper fraction is okay. So 29 over 21 is my answer. Same thing over here. I want to find a common denominator of 6, 2, and 3. My common denominator, my least common denominator, is 6. And I want to do the same thing. 6 times what will give me 6? 6 times 1 is 6, so 7 times 1 is 7. 2 times what? 2 times 3. 2 times 3 is 6, so 3 times 3 is 9. And over here, now that I have more room, 3 times 2 is 6, so 2 times 2 will give me 4. Remember, each of these fractions has to equal 1. 1 divided by 1 is 1. 3 divided by 3 is 1. 2 divided by 2 is 1. 3 divided by 3 is 1. 7 divided by 7 is 1. Each of those fractions I have to multiply by has to be 1. So now I have 7/6 plus 9/6 plus 4/6. 7 plus 9 is 16 plus 4 is 20. So I get 26, which reduces to 10/3. That is my answer. Subtraction works the same way. I want to find my least common denominator, my least common multiple. What number does both 15 and 9 go into? And if I think about it a little bit, I end up with the number 45. And so I'm going to do the same thing. 15 times what is 45? 15 times 3. So this has to be 3 over 3. 11 times 3 is 33. Subtraction in the middle. 9 times what is 45? That's 9 times 5. So I put 5 over 5 to make it 1. 4 times 5 is 20. 33 45ths minus 20 45ths is going to be 13 45ths. That's my answer. Try letter D out on your own. What is my common denominator? My least common denominator, my least common multiple is going to be 30. See what you can do with that problem. I'm going to go ahead and go to multiplication. You can pause and finish D if you like. I'm going to do multiplication and division. Let's see if I can get that. There we go. Multiplication, again, what I want to do here, since I have more than multiplication, I have multiplication and division in this problem, I want to cancel out. I want to make something to be um, what's called a prime factorization. So 3 is just 3 and 1, that's fine. 7 is just 7 and 1, but 9 can be 3 times 3. And so at this point, I want to go ahead and cancel where I can cancel. I want to think of this as 3 times 7 over 7 times 3 times 3, at which point I can cancel out these 3's, I can cancel out these 7's, and I'm going to end up with 1 over 3 as my answer. I'm reducing as I go along. I'm breaking it up into my prime factors so I can reduce things out. Over here, 5 is just, this is letter F now. 5 is 1 and 5, so I'm going to leave it. 3 is 1 and 3, I'm going to leave it. 14 I'm going to write as 2 times 7, and that 14 is gone. On 12, I'm going to write that as 3 times 4. 10, I'm going to write as 2 times 5. 9, I'm going to write as 3 times 3. Now, could I have written this 4 as 2 times 2? Yes, I could have. There's nothing wrong for me doing it this way, but I could realize it does reduce down. So now I'm going to multiply. Well, again, if I write out this step, it's 5 times 3 times 2 times 7 over 3 times 4 times 2 times 5 times 3 times 3. Well, let's see. My 3's will cancel. My 2's will cancel. My 5's will cancel. Nothing else cancels. My numerator, my top, is 7. My denominator is 4 times 3 times 3, which is 36. And there's my answer. That's E and F. Let's go to letter G. Letter G, remember division. I'm going to do these problems the same way I did letter E, but whenever I divide, I need to remember that I actually want to rewrite that as a multiplication problem. Dividing by a fraction is the same as multiplying by its reciprocal. The reciprocal of 4/9 is 9/4. You want to flip that fraction. Now I want to go ahead and rewrite this, and remember 14 is 2 times 7, 9 is 3 times 3, 15 is 3 times 5, and 4, like we said earlier, is 2 times 2. Cancel out my common factors, 3 and 3, 2 and 2. Nothing else cancels, so I have 7 times 3, which is 21, 3 times 2, which is 10, and that's my answer, fully reduced. Letter H. Letter H is the same problem. It's just, well, same kind of problem. It's just written differently because we like to use the big fraction bar instead of always using a division sign. So, but the rule stays the same. Dividing by a fraction is the same as multiplying by its reciprocal. 8 over 15, its reciprocal is 15 over 8. Again, I want to write this in some sort of prime factorization. 3 times, well, 15 is 3 times 5. 10 can be written as 2 times 5. 8 technically is 2 times 2 times 2. Let's cancel out what I can cancel out. I can cancel out 5 and 5, and that's it. Nothing else cancels out, so I am going to end up with 3 times 3, which is 9, and 2 times 2 times 2 times 2, which is 16. And that's my final answer. So you've been doing this since middle school. Why are we doing it now? Because now we're going to do this with rational functions. We're going to go to the next step. We're going to use this in more difficult problems. Please write this down. If you have the PDF, you can PDF it, but these are some good steps. Steps for simplifying rational expression, multiplication and division. Factor as many expressions as possible. Divide out by crossing out or cross-canceling, or excuse me, not cross-canceling, but by canceling exact matches. Addition and subtraction. Find the least common multiple, i.e. the least common denominator. You may have to factor it out first. Transform the fractions so they all have the same least common denominator. Combine fractions into one, and then divide out by crossing out, canceling out exact matches. That's what we're going to be doing today. Yesterday, we did 9-4. Now we're going to be working on 9-5 for the next couple days. Let's see how this works. Example 1, addition and subtraction of rational expressions. Example 1, 4 over 3x plus 5 over 3x. What's my least common denominator? 3x and 3x. That is my common denominator. So I'm going to write this with one common denominator of 3x. So this is 4 plus 5 divided by 3x. So this is 9 over 3x. The 9, remember, is 3 times 3. 3's cancel, leaving 3 over x. There's my answer, fully reduced. Let's try example 2. At any time, if you need to, you can always pause and relook at something, but I'm going to go ahead and move on. Here we go. I have my denominators of x and 3x squared. I need to have an x in my LCD, so I have an x. That covers my first denominator. My second denominator, I need a 3, so I'm going to add a 3 to my LCD. And then I need, so that's the 3. Then I need an x squared. Well, I have an x, so I'm going to put a second x by doing x squared, and that covers both of my denominators. So now I want to have a common denominator of 3x squared. This is my least common denominator, 3x squared. On the first problem, I already had common denominators, so I didn't have to do this step. Now I need to get a common denominator. Well, I have 3x squared, I have x. So what do I do to x to get 3x squared? I have to multiply by 3x. 3x times x is 3x squared. Well, if I multiply the denominator by 3x, I have to multiply my numerator by 3x, so that this is 1. 3x times 4 is 12x. That's my first fraction converted to have a common denominator of 3x squared. My second one, well, I want 3x squared to be 3x squared. Well, it's already there. It's multiplied by 1. So 5 times 1 is 5. Now I can go ahead and add this, my common denominator of 3x squared. 12x plus 5 is 12x plus 5. I can't add anything else. I can't reduce anymore. So this is my answer. There's nothing I can reduce. There's nothing that can be factored out. That is my answer. Let's try another example. Example 3. Again, now what's different here? My denominators are no longer just factors. 3x is a factor. X is a factor. 3x squared is a factor. In this page, my factors are built up of terms, x plus 3 and x plus 3, where x is a term and 3 is a term. Again, my least common denominator is x plus 3 because these already have like denominator, so I can just go ahead and add and get x plus 3 as my denominator, my common denominator, my least common denominator. My numerator is 2x minus 4. Technically, this is my answer, my final solution. I need to know, though, that it's possible that I might have to look at this and say, hey, this is now factorable. And I can factor out a 2 and get x minus 2. So technically, 2x minus 4 is factorable to 2 times x minus 2. I can put that over my x plus 3. Now looking at this, this is fully factored, but there's nothing that reduces or nothing that cancels out. So I can leave my answer either as what's in blue or as in what's in green, but this part is where I'm moving towards to see if it's factorable, if it's reducible. This particular one is not, but I might have something like that in the future. So let's try number 4. Number 4, I'm going to go put that all the way up at the top. I want to factor out my denominator so that I can see all the possible factors. My first factor is an x plus 3, so I need an x plus 3 as my factor, as my LCD. 2x plus 6, that can be factored as 2 times x plus 3, my greatest common factor of 2 coming out. Well, from the first term, I have an x plus 3, and here I need an x plus 3, I have it. But I also need a 2, so I'm going to add a 2. So for the first fraction, I have an x plus 3, got it. Second fraction, I need a 2 times an x plus 3, and I have it. So my LCD is 2 times x plus 3. So let's go ahead and use that. My new fraction is going to be, get myself a little space so I can use it. My denominator is going to be 2 times x plus 3 minus 2 times x plus 3. Let's check out my denominators. Here, in the first one, to get this to be 2 times x plus 3, I have to multiply by 2. Whatever I multiply the denominator by, I have to multiply the numerator by. So this is going to give me 2 times x plus 3, which will give me my new denominator. Well, my new numerator is going to be 2 times 2x. So that's going to be 4x. Over here, my denominator is 2 times x plus 3. I changed 2x plus 6 to 2 times x plus 3. That is my common denominator. So technically, I'm multiplying by 1 over 1. 2 times x plus 3 times 1 is 2 times x plus 3. 4 times 1 is 4. So again, at this point, I have my common denominator, my least common denominator, of 2 times x plus 3. So I can just subtract my numerators. This is 4x minus 4. Technically speaking, well, no, technically speaking, I'm still not done. I can go ahead and realize 4x minus 4. I can pull a greatest common factor of 4, leaving x minus 1 over 2x plus 3. Since I factored out that 4, these are all factors. 4 divided by 2 is 2 times x minus 1 over x plus 3. It's fully factored, it's fully reduced. I could leave my answer like this, but I a lot of times like to go ahead and distribute that 2 out and get 2x minus 2 over x plus 3. Both of these answers are correct. This one is in a factored form, and this one is not in a factored form. So either of those will work. Let's try our next example. Did I miss an example 4? I did example 4. Okay, I'm losing my mind. I did not admit to that. Here we go. Example 5 and example 6. Example 5. Example 5. Again, here I have a denominator of 3. Here I have a denominator of 4. So my least common denominator is going to be their product, 12. So I want a least common denominator of 12. Well, 3 times what is 12? Well, that's 3 times 4. I want this number to be the number 1. So 4 over 4. 4 times 3 is 12. 4 times x minus 3. Write it as, well, we're going to leave it as 4 times x minus 3 for a minute. I then have subtract. And over here, again, I need to do the same thing. I need to have a common denominator of 12. 4 times what is 12? Well, that's 4 times 3. So this, again, has to be the number 1. So it's 3 over 3. X minus 4 times 3 is going to be x minus 4 times 3. So now I can do my subtraction, but we need to be careful. I'm going to just multiply and leave it as is, common denominator, 4 times x minus 3 minus x minus 4 times 3. Here's the thing. I can go ahead and distribute out this 4, distribute out this 3 and this negative, and I can reduce and combine these. So I need to do that. I'm going to distribute the 4, distribute the negative, and at the same time distribute that 3 as well, and that gets kind of confusing. Look at it like that. But my denominator is going to be 12. Distribute the 4, I'm going to get 4x minus 12. Distribute the minus and the 3, I'm going to get a minus 3x plus 12. And I'm going to combine like terms. Negative 12 plus 12 is 0. 4x minus 3x is 1x. So I get x over 12 as my final answer. That cannot be reduced any more than it is. So not only do I need to get a least common denominator and move over to that common denominator, any type of multiplications that I have, I need to multiply out, and then I need to combine like terms and reduce so that I come up with my final answer. So let's look at something a little more difficult, and we'll look more of this in the next day's notes as well. But let's look at this last example, example 6. This is the idea of where we're moving towards, where I have a big problem I need to factor out. I want to find my LCD. Let's start with a different color. Let's go ahead and start with green. I need to find my least common denominator. To do that, I need to factor out x squared plus 2x minus 5. And remember, this is basic factoring. What multiplies to be negative 15 and adds to be positive 2. This is going to be x plus 5, x minus 3. And that's my factors for my denominator on the left. What about over here on the right, x minus 3? Well, that's already factored in x minus 3. So for my first fraction, I need an x plus 5, and I need an x minus 3. For my second fraction, I need an x minus 3. In my least common denominator, I already have an x minus 3. So that is in my LCD already. So let's go ahead and move to my least common denominator. I need an x plus 5 and an x minus 3 plus, and this needs to be an x plus 5 and an x minus 3. Well, I have x plus 5 and an x minus 3. I need an x plus 5 and an x minus 3. So this is multiplied by 1 over 1. So this factor on top is x plus 5 times 1, which is just x plus 5. Over here, I have an x minus 3, but I also need my x plus 5. So again, because I want this to be the number 1, this needs to be an x plus 5 up here. And what I did in 2 steps on number 5, I'm going to do in 1 step. I'm going to distribute this 2 through this x plus 5, so I get 2x plus 10. Now you don't have to do that in 1 step. You could do that in 2 steps, but I'm trying to go a little faster. You use a little less paper, digital paper. So now that I'm going to make it down to 1 fraction. This is x plus 5 times x minus 3. That's my denominator. My numerator is x plus 2x is 3x. 5 plus 10 is 15. But this 3x plus 5, this 3x plus 15 can be factored. I can factor out a greatest common denominator of 3. So I have an x plus 5. Then I have my original factors of x plus 5 and x minus 3 in my common denominator. And look what can happen now. I have a common factor of x plus 5. I want this fully reduced, so I'm going to cancel these. And I'm going to end up with 3 over x minus 3. None of this can be canceled because the 3 is a factor in the numerator, the top. The minus 3 is a term in the denominator, the bottom. So this is my final reduced answer. We'll talk more about this in class. I will see you later.